This is your 13th lecture, lecture number 13, about the chapter in your book, Salivary Glands. This is Dr. Siham Al-Araj, and we're gonna have a little introduction at first of the general organization, the functions of saliva, the methods of the secretion, and we're gonna have each of the major glands, and lastly minor salivary glands, and 1 or 2 slides for clinical considerations. As usual, salivary glands, the name relates to saliva, okay, to the secretion of the saliva. These are compound, tubuloacinar, merocrine, exocrine glands, which the ducts open into the oral cavity. The term compound, when I say compound, it refers to the fact that the salivary gland has more than one tubule entering the main duct. Tubuloacinar, it describes the morphology of the secreting cells. Merocrine, it indicates that only the secretion of the cell is released, while exocrine, it describes the secretion of fluid onto a free surface. These are the shape of the acini. We call them acini, shaped like berries, okay, the sacs of the end sacs of the secretory acini. They look like alveoli, so we call them either tubuloacinar, shaped like the berries, or tubuloalveolar. The same it has where secretions are, the morphology where the secretions are released, it looks like this morphology. So secretory units are tubuloacinar, and the duct system, we have a duct system, which means these cells are, the salivary glands have, they secrete through a duct system to reach the outside oral mucosa. Here is the shape alveolar or acinar. Here's the shape tubular. The salivary gland configuration is tubuloalveolar, both tubuloacinar, and it is also compound, which means we have multi-complexity of branching of the ducts. You know that the secretion of saliva, it's dependent upon taste and mastication, so it has complex integration from the salivary centers. This is what's meant by merocrine. So only the secretion of the cell is released. Saliva is synthesized by, now over 99% of the saliva is water, yet we have some inorganic and organic compounds such as proteins, glycoproteins, and enzymes are synthesized and produced by vesicles to the outside of the cell. So it's not the whole cell that is released, it's not the apical part that's released, only the secretion is released from the outside to the cell. These are the last terminal ends, the acini. They are secreted into the duct system in yellow to reach from the smaller to the larger duct system until reaching the final collecting duct. Again, this is a scanning electron microscope. It shows how the peptides and the glycoproteins are synthesized in Golgi apparatus, and then by signals from the nucleus, and then they are secreted by vesicles to the outside of the cell by merocrine pathway. When we say exocrine, it means that the gland that secretes the fluid to the free surface outside, which is the oral cavity. So it is secreted and then transferred through duct system to reach finally a final excretory duct. So we have three types of cells. We have the cells of the acini themselves that are specialized in secretion of the saliva. We have some non-acinar cells, such as contractile cells, basal cells, plasma cells, okay? And we have the duct system cells. We have different types of ducts until reaching the final excretory surface, which is of the oral mucosa, which is squamous, stratified squamous epithelium. Now, if you want to say what's general organization, first we have something called the glandular parenchyma, or the secretory tissue, and we have always supporting tissue surrounding them, the connective tissue, or what we call stroma. The glandular secretory tissue and the supporting connective tissue from the stroma of the capsule surrounding, we have a surrounding capsule around the major glands. From this surrounding capsule protecting the gland, we have passing of the septa that subdivides the gland into major lobes. For example, 1, 2, 3, and 4 lobes. And further, these septa will subdivide the lobes into lobules. So here we have, for example, a multi-lobule system. Excretory acinas, here we have each lobule have a grape-like structure in the end, which is the acini. Secretory acinas, it might be of different type of cell, okay? Either serous, either mucus, but anyway, in all ways, the septa, they carry the blood and nerve supply. We have inside the septa also what we call the fat cells. We have basal cells. We have plasma cells, okay? This is the connective tissue that carry the blood and nerve supply to the inside of the parenchyma. So we have also fat cells that increases with age. By age, we have decreased number of secretory cells and increased number of fat cells. And secretion of the saliva is under the influence of autonomic nervous system. It's not like the endocrine glands where we have the activity of hormones. The salivary secretion is influenced by autonomic nervous system, and we'll talk about it in details. Here we have the serous cells or mucus cells that secrete the saliva, fluid, salivary fluid, and then we have the acini. It is produced inside the lumen. Once the lumen, it is collected inside the or empties inside intercalated small ducts, which are lined by cuboidal epithelium, and then in turn it joins a larger striated ducts formed by columnar cells, and then finally it joins a both the intercalated and the striated, they are called intralobular, inside the lobule, intralobular ducts. And these intercalated and striated, the intralobular, are all they modify the secretion of the saliva. Now finally, when we reach the outside striated duct, they empty into larger collecting ducts, which are mainly interlobular. So if I tell you this is the great septa and in between the lobules, it's called interlobular, and it contains excretory ducts. Again, this is the grape-like composition of the salivary glands, ending with the acini in the parenchyma, responsible for the production of the primary secretion here. Now, saliva is the product of active secretory process. Okay, so it's not like the ultrafiltrate of blood. It is active secretory process that secretes the fluid from the acini cells into the duct system. Secretory product, it's either two types. We'll talk about them. But anyway, we have three types, the serous, the mucus, and the mixed type. We have something called myoepithelial cells. These cells are described as present in the acini and the intercalated, the small ducts. So they help in the secretion, and they represent what we call contractile cells. So when we say serous cells or serous acini, they produce watery, protein filled or protein rich fluid, which is the source of amylase. While if the secretory product is mucus, it means it contains proteins linked to greater amount of carbohydrates, forming a more viscous mucin rich product. The mucin, it is serous cells are named back, referring to the here. Serous cells are called back to or referring to the serum. Okay, so it's protein rich, while mucus cells are named according to the mucin, which is the main lubricant. Okay, it's the major lubricant that helps in mastication, it helps in swallowing and speech because it is viscous. Other contents that are found in the serous pieces, for example, the serous acini, we can have minerals. It contains many minerals because the saliva acts as buffer, okay, to maintain the integrity of the enamel, to maintain the integrity of it has the minerals and the ions. We have also, here we go. We have also the mucin and minerals. Also, we have peptide growth factors like epidermal growth factor, nerve growth factors. They are mostly found in the submandibular gland, okay, and they help in the, we don't know actually, but it might help in maintaining the wound healing and the epithelial integrity. Also, we among some proteins, we have cystatin, we have lysozyme that helps in the against bacteria, antibacterial effect. We have also immunoglobulins like the immunoglobulin A, it's produced in the plasma cells within the stroma of the salivary glands. It helps in the immune system, mucosal immune system. Also, we've said about the amylase, which is a polysaccharide, the polysaccharide-rich protein. We've talked about it, which is especially secreted from the serous cells. Other enzymes and other proteins are secreted, like the kallikrein, like the lactoferrin, for example, antibacterial agents, and these proteases that are present also inside the saliva. Now, the acini of the cells, the salivary glands, they are classified either according to the size into major and minor salivary glands, or according to the type of secretion. We have mucus, mucin-based, serous, amylase-based, or the mixed type. We have three major pairs of glands. Pairs, it means on both sides. So because they're major because of their size and because of their development. So they're found at both sides, the parotid, the submandibular, and the sublingual glands. And this is according to their size, from biggest to smallest. And we have what we call minor salivary glands. Numerous minor salivary glands, we have them scattered throughout the oral mucosa. They include the labial, the buccal, the palatoglossal, the palatal, the lingual glands. All of them are present throughout all the oral mucosa, exception of the gingiva and the dorsum of the anterior 2/3 of the tongue. This is the tongue. The dorsum of the tongue and the gingiva, we don't have submucosa, so we don't have minor salivary glands. Now, about the salivary secretion, this is all an introduction of the salivary glands. We have low levels of secretion throughout the day, and we have large additions or partitions periodically from the major glands at meal times, for example. Average, we have 0.3 ml per minute, so it's mostly from 500 to 700 ml of saliva is secreted each day. Okay, when we say each day, it's in a rate of 0.3 ml per minute. Now, what is really the contribution of the saliva, which is 90% from the major salivary glands. The major salivary glands, the saliva gives 90% of the saliva, and 10% are from the minor salivary glands. We have what we call very small contribution also from the gingival fluid, which is from the gingiva, and some of the sebaceous glands, but otherwise, majorly 90% of the secretion is from the major salivary glands. Now, we've said that the saliva, it is secreted by autonomous secretion, okay, nervous system. Both sublingual and the minor salivary glands are the saliva is secreted spontaneously, we say, while in the parotid and the submandibular, the secretion of saliva is non-spontaneous. We call it completely nerve-mediated. So during anesthesia, the secretion will stop almost entirely because this is nerve-mediated from parotid and submandibular gland. Now back to the salivary secretion. We have two methods of protein secretion, and we have many methods for two more methods of the constitutional pathway. Now, I can tell you that the cells, they store and secrete proteins by granules, as we've seen, upon receiving a signal. This is called exocytosis. And we have the cells continuously being secreted. It is vesicular mechanism. We have something called transcytosis. And we have what is called constitutive pathway. What's the difference? Now, salivary secretion, we have when they are stored in granules, stored granule exocytosis. This is upon a neuronal signal. So most likely each secretion has a duration of 3.5 hours until prepared, okay? Until they reach from the nucleus to the outside exocytosis from the cell membrane. They need almost 3.5 hours. While in the vesicular mechanism, it's continuously secreted. So about in half an hour, okay, the saliva is secreted from Golgi directly to the plasma membrane or to the lamina, into the lamina, okay? From Golgi to the plasma membrane, and this is called a constitutive pathway because it's from the basal to the luminal surface of the cell. This is called constitutive pathway. The vesicular mechanism, here you go, vesicular mechanism, it is continuously from the Golgi to the plasma membrane, while the constitutive pathway, it is from the cell to the interstitial tissue. Now we'll know what is the interstitial tissue. There is a tissue surrounding each type of acini. We have either transcytosis, for example, for the immunoglobulins and the IgA and IgG, they are secreted from interstitial tissue to the apical cell membrane, to the basolateral surface of the membrane, and this is called transcytosis. If we have it oppositely, from the cell to the interstitial fluid, it is called constitutive pathway. And there is a demo in the, I will show you in the summary in your book about the interstitial and about the constitutional pathways. Protein here, it is synthesized in the rough endoplasmic reticulum, transported via the Golgi apparatus, and then here we call transphase of the Golgi apparatus. That's why we call transcytosis. And then initial storage within immature granules. And finally, we have exocytosis of the stored proteins. Sorry, secretion into mature, they become more mature. Here is immature granules, and then more concentration of proteins in mature storage granules. Finally, they will get exocytosis of the stored protein into the lumen of the acinus. The lumen, the space, the empty space of the acinus. And we've said already that some types are nerve mediated, some types are spontaneously mediated. We have two types of either serous or mucus, and they are different. We have some differences between the serous end acini and the mucus and acini, which secrete small mucin. Now the difference, both of them are wedge-shaped or triangular in shape. But for example, we'll start as an example of the serous acini, the parotid gland. And as an example of the mucus acini, the sublingual or the minor salivary glands because they are full of mucin. The parotid gland, it's the largest salivary glands, and it is present, as it's called, parotid. Paro, it's around the ear. Okay, so it's called parotid. It's around the ear, so it's the furthest, the most far from the oral cavity. This has a long duct system. The parotid gland has a very long duct system. It has a very defined parotid capsule, so it should be, because it's separated from the oral cavity, so it has a very large capsule, and thus, because it has a very long delivery system, okay, or duct system, it needs to be more serous or more watery in constitution. So mainly, this is most likely serous acini, except for some occasional mucus cells found in children. Okay, in the child parotid, at first they have mucus cells. By age, they become more and more serous. Now, the septa that are found here, they divide the gland into lobes and lobules. We have blood vessels, nerves, and collective ducts, as we've said. The lumina of the acini in the serous part and parotid gland of the parotid gland is very narrow. Okay, we have very narrow, and the secretion is watery, so there is no problem. Now, under the microscope, the serous cells have a granular appearance. We have much granules that are because it is rich in protein, remember? So the cells have the prominent nuclei, round nuclei located at the basal third of the cell, which is basophilic because of the presence of the rough endoplasmic reticulum. So we have a granular appearance of the serous cells from the numerous granules that are found in the luminal portion of the cell, adjacent to the lumen. We've said it is very small lumen, and the cells produce granular appearance under routine hematoxylin and eosin staining. The ultrastructure appearance, I've returned back here. The ultrastructure appearance of the serous acini, here it's illustrated here. We have a wedge-shaped outline, the basal surface being broader here, the basal surface, while the here it surrounds the central lumen. The luminal surface here, it surrounds the central lumen. The cell membrane, it shows numerous microvilli and enfoldings. The basal part of the cell here, the basal part of the cell, each serous cell is delineated from the surrounding connective tissue by something called the basal lamina. Okay? The basal lamina between each epithelium and connective tissue, we have a basal lamina. So this basal lamina, or this region of the cell here surrounding the connective tissue, it contains the nuclei and the rough endoplasmic reticulum and capillaries seen proximate to this surface. We have luminal part of the cell. Also, it contains dense and round secretory granules. We have many what we call canaliculi here. The canaliculi, or small canals, okay, that run between the cells and they join the lumen, the major lumen, or the common lumen. Both the canaliculi and the lumen, they are lined by microvilli, as you can see. Adjacent cell membranes, they contact each other by means of desmosomes, multiple desmosomes, gap junctions, and tight junctions. So, as we have said, over 99% of saliva is water. The water passes across the cell membrane, which we call transcellularly, or between the adjacent cells, called paracellularly, as a result of the secretion into the lumen. We have a protein-rich, we call it protein-rich or proteinaceous components. They are packaged in granules for release into the luminal system by means of exocytosis. The method of secretion, which is called exocytosis, to the liminal surface of the cell. So for this reason, you see that the cells are highly polarized. Proteins in the serous cells are assembled by ribosomes, and we have rough endoplasmic reticulum, and we have some Golgi material. Okay, all of this help them to become more electron dense. As the protein content is more concentrated, it becomes more electron dense. Here you go. The protein content here, it becomes more electron dense under the microscope. So the proteins are being glycosylated, and it is released in vacuoles, which become the secretory granules here. Okay, they are at first they are immature, and then they become more mature, concentrated, and finally, following the maturation, the granules discharged by exocytosis when required. The mitochondria within this cell, it supplies the energy for synthesis and secretion of the granules. As we have said, the appearance of the serous cells, high levels of secretion activity. So after the synthesis of the secretory products, which are here at the luminal parts, here in the cytoplasm, we have the stimulation, multiple stimulation by mastication, by mealtimes, at mealtimes. Finally, all the cells, all the granules are secreted outside, and the cell is discharged. So we need more ATP to more energy from the mitochondria to again initiate this secretory and synthetic process. Now, as a nerve supply for the glands, we have sympathetic and parasympathetic nerve nourishing. Okay, it is, as we called, autonomic nervous system. So the parasympathetic by acetylcholine, and the sympathetic by norepinephrine. The parasympathetic, here it helps the what we call formation and secretion of the saliva, while the sympathetic, it helps increase the output of the saliva. We have also two other definitions, that some neuroeffector cells, the neuroeffector sites, sometimes it's found beneath the basal lamina in direct contact with the cell membrane, so it's called hypolamal, where we found the affecting of the neural affection, it is found beneath the basal lamina, while in other sites, the neuroeffector sites, they remain outside the basal lamina, so we call it epilamal. Both the sympathetic and the parasympathetic, they cause the contraction of the myoepithelial cells. So here it's beneath the basal lamina, and here it is outside the basal lamina, the epilamal. I don't know, there's no diagram. There's a diagram in your book that helps you visualize what's hypolamal nerve supply and what's epilemmal versus nerve supply. Each of them has either secretion and synthesis or increase of the output, and both of them have a control over the myoepithelial contractile cells. Now, the duct system in the parotid gland, it is intercalated, striated, and collecting ducts, as we've said. The intercalated, it's called the smallest and the most distal of the ducts. It's called, it means away from the membrane, away from the oral mucosa. It's called the intercalated duct because it is squeezed or compressed usually between the acini. It's lined by cuboidal cells, the intercalated ducts. Cuboidal cells, you see that these cells are least differentiated. The nuclei in the duct cells appear prominent because they have scanty cytoplasm. And at the ultrastructural level, you can see that the intercalated ducts consisting of simple cuboidal epithelial cells. Both have luminal side and a basal side. Both luminal and basal side of the intercalated duct are smooth. We have desmosomes uniting the adjacent cells. And there are only small amounts of organelles normally associated with protein synthesis. These intercalated, they contribute primarily to the secretion, or what we call primary secretion of the saliva. Several acini, they drain into the intercalated duct in the parotid gland, and they are characteristically long, narrow, and branching. Okay, because we have watery secretion of protein synthesis. Second duct system is called striated ducts. Also, they are we call them intralobular. They are inside the lobules, intralobular, and they form a much longer and more active component of the duct system than the intercalated. These cells have large amount of cytoplasm. They are larger. They are more columnar in shape. Large amount of cytoplasm, large spherical, centrally positioned nucleus that you can identify here. Centrally large spherical nucleus, and these cells can be easily identified through their nucleus. Okay, they are highly polarized, columnar in shape. Their luminal surface have a short microvillus border. Okay, the duct, when we say the basal surface, this is the luminal, and this is called basal or abluminal surface, we call it. This is which is adjacent to the basal lamina, separating it from the connective tissue. It shows numerous here striations in the light microscope. Thus, it is called the striated ducts. Ultrastructurally, these striations, they correspond to multiple enfoldings of the plasma membrane that is vertically aligned. We find mitochondria that are packed between these enfoldings. The adjacent cells have also anchored by desmosomes. The large surface area for the microvilli, it supplies more levels of energy from the mitochondria, which is involved in active transport of the ions. The striated ducts thus have electrolyte resorption of sodium and chloride ions, and electrolyte secretion, potassium and bicarbonate, without the loss of water. So as this resorption is against the concentration gradient, it requires substantial amount of energy. So we want to convert the isotonic saliva into, this is the striated ducts. The isotonic saliva that's produced early in the acini and in the intercalated, here it's transferred to isotonic or to slightly hypertonic fluid, to finally hypotonic fluid. So the striated cells, they exhibit secretory granules on the luminal side, some epidermal growth factor, lysozyme, kallikrein, what we call the secretory IgA also. Okay, the granules we have are less present here in the striated ducts, and less abundant in the parotid ducts. Okay, in the parotid gland, sorry. Okay, the striated ducts, they lead to larger, what we call larger collecting ducts. It is the final stage of modification of saliva. It is called collecting ducts because they only collect but not modify, whereas we have the intercalated and striated ducts that modify the composition of the saliva, as we have said, so we call them secretory ducts. But this final collecting or excretory ducts, we have, in addition to a columnar layer, but we don't have striations, okay? Columnar but unstriated cells, sometimes they look as pseudostratified. The collecting duct, they are found, we call them interlobular regions, interlobular in the large connective tissue septa. And as it enlarges and enlarges, we have what we call the main parotid duct appear like excretory passages. Two layers. We have mucosal layer and outer connective tissue adventitia, we call it. Near the termination of the lining, the main duct, it becomes more stratified as it merges with the stratified squamous epithelium of the surface oral mucosa. Okay, the surface epithelium of the mucosa. When it is stratified, you can see the duct system, the duct epithelium. It contains near the becomes it's stratified near the surface, so it contains some cytokeratins. Okay, intermediate ligaments, as mean. Now the myoepithelial cells, as found, they are found in the between the basal lamina and the basal membranes of the secretory cells, which means the acinar cells and mostly the intercalated duct cells. These cells are have many functional roles. Okay, at first they have their appearance under the microscope has the radiating processes, dendritic cells. We have shorter processes around the intercalated ducts, and they contract in response, as we said, to sympathetic and parasympathetic stimulation. Flat cells, synthesizing organelles, desmosomes and hemidesmosomes with the basal lamina. And here are the functions for myoepithelial activities. Here you go. So we have 8 functions for the myoepithelial cells, most notably the first 4, okay, which is supporting the underlying parenchyma, reducing the going back of the fluid, okay, here you go. And we have also what is called accelerating the initial flow of the saliva, reducing the luminal volume, and adding to the secretory, what we call pressure, secretory pressure inside the acini, and helping the salivary flow to overcome the peripheral resistance, because if it's very excessive, we will have damage of the striated ducts. We need increasing overall permeability from the outside, from the acini towards the outside surface. Other possible functions like assistance of the parenchymal cells to expel contents, like milking effect of the extracellular fluid, and passage through tight junctions. It has also an anti-cancer effect, the myoepithelial cells, which is found in your book. Because it has, as we've said, both cytokeratins, which is an epithelial factor, and also it has actin components, okay, the actin and myosin, which is the muscular markers, okay. Now, having finished about the parotid gland, all the other major glands are easy. Submandibular gland, we've already taken a break. So submandibular gland, it is the second largest after the parotid. Here it is a mixed serous and mucus, but with more predominance to serous secretion, almost 7-3 in predominancy. Okay, it has a surrounding capsule, of course. The serous acini, they are similar to the parotid, what we've said, and we has plus a here you go, the mucus cells. Now what is different about mucus cells? That the collections of mucus acini with the submandibular gland here are distinguished from the rest of the gland. We can see darker staining and granular, as we said, in the serous, we have dark staining and granular serous acini. But here we have the mucus acini are more pale since they have mucin content. So they don't take up the routine stain, hematoxylin and eosin. In addition, we have the nuclei tend to be compressed into the basal part of the cell. We have a small crescent-shaped serous cells that are found around the mucus acini. So we call them serous demilunes. I'll show you here. These are the serous and the mucus and the serous acini in demilunes, and this is the lumen, the connective tissue, sorry, in between. Both serous and mucus, they align to a common lumen between them, but we say that differently. We have on the ultrastructure that the method of preparation for the histological section, sorry, we have mucus cells distinguished readily by the stages of synthesis for the secretory products. We have larger amount of endoplasmic reticulum. We have present in mucus cells. we have fewer secretory granules compared with the serous cells. We have also more Golgi apparatus. We have, it gives contribution to the carbohydrates that is added to the secretory component. It's protein plus carbohydrates to give it more viscosity. Okay. In the final stage of the secretory cycle, the mucus cells will exhibit more isolated, numerous secretory granules. And how do you distinguish them from the serous? By their pale appearance. The vesicles have pale appearance. The cell membrane here shows fewer microvilli and enfoldings than the serous cells on both sides, okay? The nuclei, you found they are round and central, the serous demilunes, they are found around the mucus. So the mucus is in the center and the serous is in the surrounding, as we've seen here. Serous, darker, and mucus cells which are pale in color. And they both secrete into a lumen, a common lumen, as we've seen in the diagram. Now the duct system of the submandibular gland, it's very similar to the parotid. We have intercalated ducts, but much shorter. We have striated ducts are longer and more obvious. In this section, the striated ducts, here you go. All of these are striated columnar lined ducts. Final major salivary gland is called the sublingual, located beneath the mouth, the tongue, sorry. And this is made up of two parts, major sublingual gland, in addition to minor glands, a collection of 8 to 30 minor glands. Each of the glands has its own system of emptying outside to the sublingual fold. The major part of the sublingual gland is also mixed, but with predominance of the mucus to serous. Okay, so in the sublingual gland we might have almost 3 to 7 or 6 to 4. The predominance is to mucus cells. I don't know if I see here. No, but anyway, the posterior part is called greater sublingual gland, and the anterior part is called the lesser sublingual gland. This is all major gland, which is mainly mucus. Now the minor salivary glands are totally mucus elements, okay? And both of them, the major and the minor, they're empty into the sublingual, what you call sublingual folds, okay? The sublingual gland has, in routine staining, we see it as many groups of pale staining mucus cells with darker, there's no histological section, but we can see some darker staining serous acini and serous demilunes, but most of it are the pale staining mucus, okay? The histological structure of all of these glands are similar, whether greater, major, or lesser major, or minor salivary glands. As for the duct system, we have less developed duct system than in the other major salivary glands. We have striated ducts are usually absent. The acini, they lead to intercalated ducts at first, and these may be absent also because the acini will lead directly to collecting ducts. Collecting ducts, they lack striations. We've said there's no striations for the collecting ducts. So sublingual saliva, it's therefore more rich in sodium. We don't have this substitution of ions that happens inside the striated, full of striation ducts. We have already emptying into the collecting ducts, and independently, the greater drains into main duct, the lesser sublingual drains to the smaller ducts, and they all open to the sublingual mucosa. This is the diagram from your book. Last part is the minor salivary glands. Classified they are by anatomical location. So we call them buccal, labial, palatal, palatoglossal, lingual. They are estimated to high number, okay, of minor salivary glands from 500 to 700 in number. Primarily, they are mucus, except for one part of serous glands, serous minor salivary gland, which is called von Ebner's gland, that drain into the trenches of the circumvallate papilla and the tongue. Remember? All the labial, buccal, palatoglossal, and the palatine are all mucus in predominance. The minor salivary glands have collecting ducts, and intercalated and striated are absent. So they have only collecting ducts that give them access to the outside of the oral cavity. So you can say that the protein synthesis, it's much less. The mucus secretion here, it's entirely mediated by parasympathetic nerve impulses. We've said it's nerve mediated in both the minor salivary glands and the sublingual glands. And we've said that the minor salivary glands secrete spontaneously and continuously. So does the sublingual glands. This is a final summary. Difference between serous and mucus. Finally and lastly, the clinical considerations will have very, very rapid for the salivary glands about the dryness of the mouth, which we call xerostomia. Okay, xerostomia, which is dryness of the mouth. It can happen due to many factors. For example, old age, because we have less secretory components and more fat component by age. Some medications may contribute to dry mouth. Radiotherapy, for example, a syndrome of autoimmune origin, which is called the Sjogren syndrome. Okay, it also contributes to xerostomia. Okay, now the age changes, if we want to say just only about the age changes, it's documented that we have more amount of fibrous tissue, fat cells, inflammatory cells,